Dear learners, our topic of discussion today for this session is minimal processing. You have studied already food processing, you have studied the method of preservation, whereby the canning is there, freezing is there. And in canning, it is very high temperature which we use. But consumer wants a product in today's scenario should be near natural product. So in minimal processing, you will basically learn that what are the approaches for having processing, extending shelf life, but we are attempting or we are modifying the product to the minimal extent. So this would be the key learning out of this session. Now, you might have the first question that what is minimal processing? How to define it? It can be defined as it is a way to alter natural foods while preserving their fresh-like quality and extending their shelf life. So what are the methods which could be included for this purpose? Here, if there is a fresh harvested product, if like there is a cauliflower, you would like to remove the outer leaves, you would like to cut the below that harder portion which is a stalk attached to the plant, and there you are cleaning, sorting, peeling, trimming, deseeding. So those all operations would be considered as a removing unwanted parts. Once you have done this, now your objective is also to extend the shelf life. So whereby you will target for, say for example, if there is something where we can remove certain impurities, filtration. You can slightly improve the palate and also reduce the moisture, roasting, pasteurization. Sometimes in fresh whole commodity, we give slight hot water shock, which is called as scalding. There could be other processing methods like fermentation, packaging. They can also be included as an intervention for minimal processing. Ultimately, focus what is there that you are combining different processes. It can also be named as hurdle approach. And thereby you are targeting for preservation or also maintaining sensory properties like aroma, taste, texture, and the visual appeal. Visual appeal, you can also have a visual feel of minimal processing product like this. You would have seen the product like this in the market. Another product in this line is the packed pomegranate arils which are available in the market. So this kind of products are classified under the minimally processed foods, and more so because you are putting the food near natural. Mainly it is there could be some processed. That means there are two approaches. Shelf life is there, and sometimes you are reducing that extra part that's for the fresh produce. But sometimes it is also aimed for the processing. Then high pressure processing example, which you will study in a separate unit. That can also be counted as a minimal processing, whereby you are minimally influencing the juice taste or the sensory properties. For fresh fruits, it is largely applied. This concept is largely applied for the fresh harvest or the fresh foods. Harvest could be the fresh agro harvest. There could be some of the products which are animal origin products, and then they can be termed minimally processed fresh foods. Fresh cut fruits, they will appear in the market particularly because consumer is looking for such products. The consumer wants good quality in terms of the nutritional and also in terms of the taste. So you are making it ready to eat. So the convenience factor is added. So fresh cut fruits is one of the key example in this class. So convenience is there, and whereby you have given certain packaging, maybe modified atmosphere packaging, added with the low temperature storage, and the extended shelf life is available for 7 to 10 days. That is the outcome of this particular product. How do we achieve it? what are the process or the, you can say, the unit operations involved in it. So they are explained here in this process flow diagram. Once you receive that fresh harvest or the fresh produce, you have to first make it ready. If required, you can put it for pre-cooling, and then washing, disinfection, and size reduction or the peeling if required, and then whatever treatment actually you are giving. So they are the key processing steps, and how, to what extent you can keep it near natural, that would be important, and that will really give a meaningful or impactful product in the market, which would be classified as the minimally processed product. Challenges and the concerns which could be there with such products, they could be physiological phenomena, because physiological change, you are putting the product which is still a live product under the physiological stress. So that will also lead to certain biochemical changes. Obviously, there could be the presence of microbes. This is not a sterilized product. So how do you really cope up with the microbial spoilage or the challenges posed by the microbes or microorganisms? So that is how you balance on the process, and with your intervention of this kind of processing, you will address the degradation, which could be in color, which could be in texture or the flavor of a fresh produce. And that is how the process is there. First and foremost thing is the challenge which is there due to the microbes or the hygiene related requirements for processing products, which is for a processing facility targeted for the minimally processed food product. As we are removing natural barrier, which is peel or the skin of the product, so it means it is exposed to the extreme or external conditions where microbes are also naturally present. So microbial risk is increased. And for this purpose, even before peeling, the surface microbial load reduction, which is naturally available from whatever the source it is would have been collected, so that disinfection needs to be, the commonly wash or the washing can be done with a disinfectant like chlorine. And further cleaning operations, pressure wash is there, and we can have the cleaning operations of the field bins, or you can say that drenchers, storage chambers, so that overall surface load is minimum. That is the supply chain back-end interventions to be done for the having good quality fresh produce which is minimally processed. And there has to be consideration for good manufacturing practice, good hygienic practices, whatever the SOPs which are meeting the requirement of GMP, GHP or schedule FSSAI requirement of schedule 4. They would be important. In this regard, it would be good to have a good quality product and to put in place hazard analysis and critical control point, identifying what are the critical point for making the product safe. Now, keeping the product near fresh. So what are those important points? Ultimately, when the consumer will consume, he or she will judge the product on the basis of eating and nutritional quality. Nutritional is a hidden attribute, but certainly eating is the quality attribute which our consumer will certainly going to grade or judge our product on that basis. So that is a complex interaction which we understand through the sensory evaluation, which is done before sending the product outside. And finally, overall, what nutritional impact has been there of the processing. And it is judged, or the fresh produce quality components, they can be judged through, or they could be evident through appearance, texture, flavor. Appearance means what? Like if there are apple which is pre-cut, sold in the market, what is the degree of brownness, or you can say the browning on the surface of the apple? Which surface? Which is a cut whiter surface or slightly pale surface. That should not appear as brown. Sometimes some glossiness if it is a whole product, cleanliness of the product, There should be no shriveling or wilting, whereby water loss during storage. So means sometimes what do processors do? They apply certain coatings. They can prevent the water loss. The texture quality can be hardness, crunchiness, because you have cut it. It should not lose the proper texture, which is a near natural texture. Flavor perception, because that is very sensitive attribute. Now, product has been maintained well, looking good, but whether or not it is safe, that question also comes, because the product is exposed to the market and it is not sterilized, and it is not using, say for example, those conditions like canned food, where they are placed and canned and they remain good for long time, even at the ambient conditions. So here, general microbiological aspects are taken care. What is the working principle, how product is being handled, whether the handlers are using gloves or not, what is the frequency of change of gloves, what is the temperature of processing zone, usually kept at 8 to 10 degrees centigrade advisable. Packaging section even can be kept little lower than this. If there is a mechanical peeler is there, how frequently we are cleaning it, and we are not allowing the cross contamination. How do we change the, say for example, we are washing, what's the change cycle for the water which is being used, whether it is having a disinfectant or not. And there could be a newer approaches for it, like we can sanitize those solutions with ozone, ultraviolet. So there is a possibility to apply some novel processing techniques. For example, washing, which I was talking, what is the importance of proper washing? If we will not properly give the wash, it means the washing and sanitization ultimately targeting removal of agrochemicals, so which is pesticide residue otherwise will be there. Plant dervis could remain there if we will not properly wash. And the microflora which is coming along with it, over the time it will increase, and then it may lead to the fermentative spoilage, like lactic acid bacteria or the yeast. They can cause the damage to the product which is pre-cut, fresh harvest. There could be like fermentative species of the yeast. They can naturally grow on the surface of the fruits, and they are capable of causing fermentative spoilage of the fruits. And in case of other important quality consideration, the color change. Color, there is a biggest challenge is from the enzymes. We have cut the surface, the exposure to the oxygen and sunlight is there. Many oxidative enzyme systems which are naturally present inherent to the fresh produce, they will activate, and their activation may lead to some aesthetic change in the product. Here it is shown that how the ethylene would have that can induce yellowing of broccoli. Which broccoli would be liked by the consumer? Certainly the green, good green top line only. And for this purpose, how do we address the enzymatic change? We might not inactivate through the thermal processing, but we can at least make the enzyme or the environment such that enzyme is not active. It is not using the substrate. For example, enzyme like polyphenol oxidase, how do we influence the environment? Means dipping in a certain solution, they could influencing the pH, or also some antioxidant combinations can be given, and then the browning of the pre-cut slices can be reduced. Further, I mentioned that playing with the pH for this acidification, whereby we can use acetic acid, ascorbic acid, citric, tartaric. They are the natural food acid. They could be of the natural origin, they could be synthetic, but imitation of the natural. And quite often, the combination of these acids can also be used. I mentioned about that antioxidant or the reducing agent. Ascorbic acid is one good example for it. And it can prevent the browning of fresh cut. Application of edible coating is can also be put to the slices or the cut portion. Sometimes edible coating is also applied for the whole fresh produce. And for this purpose, sodium caseinate, stearic acids, there could be examples. Even people have used some other proteins or sometimes protein and starch matrix taking together and using it as the coating on the surface. Sometimes some natural antimicrobials can also be added to it, which could be the part of the coating. And they can, like for example, here it is mentioned cinnamon extract and chitosan, which is an animal origin normally a byproduct as a polysaccharides and having antimicrobial properties. Similarly, like application of vanillin, a dip which is at around, you can say that 80 milli normal kind of solution can be used, and at 5 degrees centigrade it can play as an effective role of reducing the microbial population. And that's how we'll give a detailed account, a list of those natural antimicrobial later. So the most important intervention in terms of this processing is in this the flow diagram which we referred earlier. I have just truncated it and brought it in this figure. So what antimicrobial agent you are selecting, what anti-browning agents are being selected, or texture preservative if they are there. Some firming agent can also be applied for keeping the texture firm. And in this regard, there could be different approaches, like some packaging level intervention, changing atmosphere of the packaging, modified atmosphere packaging, giving us some physical treatment like irradiation, coating we have just talked already, putting some natural preservatives or new preservatives, novel preservatives like bacteriocides. You will also study, or you would have studied, I believe, that in one of the unit about novel processing technique where pulse electric field, intense light pulse, ultrasonics, ultraviolet exposure, high hydrostatic pressure, they can also be selected for minimal processing. Now coming to that critical step of disinfection, where normally chlorine was being used, but there are concern about the residue of chlorine. Some of the countries have banned. People are looking for alternative of chlorines, like chlorine dioxide is one of the permitted, FDA approved, which is permitted for the US purposes. And here, what is it? It's a water soluble yellowish green gas, and chlorine oxide, when it is there, it may produce some hazardous byproducts such as chlorite and chlorate. So that needs to be looked into. And chlorine dioxide, however, it is permitted up to the level of maximum 200 ppm. So that quantification is very, very important. Its limit should be considered while we are using it. There could be alternate like acidified sodium chloride, which are alternate salt. It is also permitted, approved by US FDA and also permitted by other countries. And its spraying or dipping can disinfect the surface. More eco-friendly or green solution is available in form of the ozonation of the water and then using it as for the wash purposes. And ozone rapidly undergoes the spontaneous decomposition and at high pH and leading to the production of the oxygen, which is non-toxic product, and that's how it is considered safe, and it's a glass kind of chemical and suitable for purpose of the disinfection. Ozone concentration can be used from 0.5 to 4 ppm for the washing purposes. Electrolyzed water is also a newer approach whereby we can use the water which the pH is influenced due to the electrolyzation of the water. And when we put it water and there are two electrodes, the one electrode side it is acidic, other side basic water is there. So particularly in this electrolyzed water, the water which is of the pH 2.1 to 4.5 range, that can be used, and it contains some acidic because there is a degradation of the water and HOCl is formed, and that is the antimicrobial component which is available in this. It can even handle with the E. coli, which is available on the surface of the food material, and thereby it is disinfecting. And particularly E. coli O157 kind of strain can also be handled. Listeria monocytogenes can also be addressed through this water. They can be disinfected. Good CFU reduction can be there. Sometimes we give the combination like UV is along with the ozone. Then the ozonization with the UV light exposure can be there. This is commercially very well accepted. Some of the patented methods are available using it. They can give the 3.3 log reduction in one of the study which is reported in this, that UV light at a wavelength of 253.7 nanometer applied on the apple, this is a stress study. So means there is an apple slice inoculated with the E. coli, and it is observed that 3.3 log reduction is observed in the E. coli. In addition to this, if the 0.3 ppm ozone exposure and the aerial growth of different mold can be seen that it is inhibited. That is also a challenge study where peach wound was inoculated with the target molds, even where the penicillium was also there. Now, I would like to inform you about the different sanitizers which are there. Like chlorine is one. We have the chlorine alternatives. We have just also seen like chlorine dioxide. In addition, there could be certain, for example, peroxyacetic acid, ozone, the kind of concentration and the pH which could be effective. So that is depicted here in this particular slide. And in case of the bioactive or the biocontrol measures, some biocontrol agents like they could be biopreservative, which could be lactic acid bacteria, bacteriophages, natural antimicrobials, which could be bacteriocins produced by certain bacteria. And you see the right side, the effect, they are effective against the pathogens. They are effective against Listeria monocytogenes. They are effective against Staphylococcus aureus, Bacillus cereus. They are effective against Salmonella species. And some other normal flora they can also be effective against. So that is an alternative and near natural kind of, that will really make your product to claim as a minimally processed. Modified atmosphere packaging is also one of the way that we handle after processing it. We put that produce because it is still having, you can say that if it is a whole fresh produce, which is respiring. So there is a respiration is there. Biochemical changes are taking place. So MAP systems, which are called modified atmosphere packaging system, they are used for the fresh cut fruits and vegetables to prevent water loss, respiration rates, cut surface browning, microbial growth, and also the ethylene biosynthesis kind of action. So these all things can be addressed with, you are modifying atmosphere within the package. How do we modify it? So for example, a packaging example in the last point indicated the reduction in the oxygen level. You can increase oxygen, or you can increase, or you can make a balance between oxygen and CO2 rather. So that less oxygen is available, so oxidative changes are less. So they could be effective through reduced respiration rate, and also will give that what atmosphere means in terms of the temperature you are providing, accordingly the rate can be controlled. And in terms of some recent highlights, so what technologies, recent technologies are available. Here some consumer units of the fresh cut produce, they could be used, and they can use oriented polypropylene films. What is the advantage of this? That they can give a better clarity, so high clarity, the product selection can be good gloss will come, and stiffness, and for a good consumer appeal. They have the good oxygen transmission rate, and this cyclic olefin copolymers, if we take, that is incorporated in the polyethylene films, they can provide a higher stiffness characteristic, particularly to this oriented polypropylene film, and they can maintain further better oxygen transmission rate control, and they can be if we look for the packaging technologies, they could be applied for the extrusion technologies, develop a patented process, producing which are patents are available. They claim that such films will give you a better packaging for modified atmosphere package options. There could be bag in bin kind of options, bag in carton in options, whereby they have very specific properties. You just what do they do? They are basically, if there is a product where you have already processed it, brought it into the cut surface, and you have used certain antioxidant over it, you have given the UV light exposure, so it will take care of the browning. But further, it can be packed with this bag-in-box kind of system. How to address this CO2-O2 interaction, and depending on the temperature. Number one, CO2 should not be very high, so that respiration is leading to anaerobic respiration and will develop off flavor. And if there is an oxidative kind of changes, it will degrade the quality of the product, softening of the product. And so the balance can be naturally arrived through the certain smart, you can say that chip which is applied. It's a polymer which is a perforated, and it is temperature sensitive. If the temperature is high, opening would be more, so that more release of CO2 can be come out of it. So that kind of applications have come up, and people are trying to give good quality of modified atmosphere storage products for the consumers. They are minimally processed and then modified atmosphere packaged. They can stay fresh for a longer time. So this is how the operations are carried for getting a product which is minimally processed, and with the aid of packaging or with certain other agents or coatings, they can stay long, good shelf life, and consumer may relish a product which is near fresh. So that is all for this session. Thank you. All the best.